Hi everyone, welcome to section 3.1. In this section, we are going to be discussing inverse functions. So inverse function is the name of this section. We are going to first identify what does it mean to be a one-to-one function. So by definition, a one-to-one function is a function f is said to be one-to-one if for all a and b are in the domain of f. So if A is not equal to B, then f of A is not equal to f of B or equivalent. If f of A is equal to f of B, then A equals B. So let's look at the first one. Determine if the relationship defines Y as a one-to-one function. So every value of X has to have a different value. So if I actually like to have these as eggs. So my X1, my X, my Y, my X, my Y, my X, my Y, my X, my Y. So then 2 will go to 1, and then 4 will go to 2, 7 will go to 3, and then -2 will go to 1. But wait a second, we already said that 2 goes to 1. That means that it has to go back to 2, not to -2. So because 2 and -2 are different x's, but go to the same y, this is not one-to-one. So 1-to-1, you have to go back to the original value. So 2 goes to 1. That means that 1 has to go back to 2, not to -2, not to a different x. It has to go to the same x. Now look at the next one. Look at the arrows. Batman will go to Joker, Green Lantern to Sinestro, and Wolverine to Sabretooth. So each has a distinct y value, and the y value has a unique x. Has a unique x. So this is one-to-one. Every x has to have a y, and that same y has to return to the same x in order for this to be one-to-one function. Now, a function f of x is one-to-one if no horizontal line intersects the graph at more than one place. So it has to pass the vertical line test. See, it only touches it once, 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 once. This is yes, one-to-one. It passes the vertical line test. Sorry, it passes the horizontal line test. Now, that's for number 3. Number 4, if I do this horizontal line test, it crosses it once, twice, 3 times, 4 times, 5, 6, and 7. This fails, and it's not one-to-one. It does not pass the horizontal line test. And then here, again, one time, one time, one time. This is yes, one-to-one. It's a one-to-one function because if I pass the horizontal line test, it will only touch one time. So we saw it as a relationship and we saw it as a graph. What if I have it as a type of a function? So use the definition of a one-to-one function to determine whether the function is one-to-one. We want to show if f of a is equal to f of b, then a is equal to b. So the first thing we would need to do is find f of a is 3a plus 2. F of b is 3b plus 2. We're going to set them equal to each other. So equate f of a is equal to f of b. That means that 3a plus 2 is equal to 3b plus 2. Then we solve, we subtract both sides by 2. We get 3a is equal to 3b. We divide both sides by 3, and we get a equal b. So then this is yes, one-to-one, because f of a is equal to f of b, and a is equal to b. So that works. That is one-to-one. Now, the next one, we're going to find f of a, which is 3a squared. F of b is equal to 3b squared. Now let's equate f of a as equal to f of b, which is 3a squared is equal to 3b squared. Okay, well then that's divide both sides by 3. That gives you a squared is equal to b squared. Well, wait a second. If I take the square root of both sides, I get a is equal to plus or minus b. So it's not 1 to 1 because I have two values. Because I get a plus and a minus. I obtain more than one value. So again, it has to be unique, not 1 to 1. Alrighty, so then what's the next step? We are going to look at inverse functions. We needed to work with 1 to 1 before we go to inverses. So we want to determine whether two functions are inverses. The first condition is that f must be a 1 to 1 function. If f is 1 to 1, then you will have an inverse. Then g is the inverse of f. Alrighty, so the first condition is the composition of f of g of x is equal to x for all the domain in G, and G of x is also in the domain of f. So we're going to have to look at the composition. So we're going to have to look at the composition to verify the inverse. So that means that f of f inverse of x will give you x, and f inverse of f of x will be equal to x. So we should end up with an x. So we want to determine whether the two functions given are inverses. Remember, we want to show that they are inverses, so we have to show that f of g of x is equal to x, and g of f of x is also equal to x. That's what we want to show. That's what we want to show, if that's true. So the first hint is f of g, so it's going to be f of 1/3 x minus 2. I'm doing this case first. So that's going to be 3 times 1/3 x minus 2 plus 6. Alrighty, so let's go ahead and distribute. I'm going to get x minus 6 plus 6 gives me x. So this is x equal x. So the first part is true. We just checked that f of g of x is equal to x. Now let's show the second part. Let's go over this side. I'm going to do it in purple. So now it's g of 3x plus 6. That means I'm going to do 1/3 times 3x plus 6 minus 2, and that should equal x. Okay, well, if I divide it out or multiply it out, I'm going to get x plus 2 minus 2 is equal to x. Therefore, x equal x, and we verified that both conditions are true. So f and g are indeed inverses. So yes, they are inverses. Now we are going to do the same thing with f of g of x in this case, and we want to show it's x. So let's go ahead and do that. So in this case, it's going to be f of 5x plus 1. It's going to replace all this for x. So it's 5x plus 1 over 5. And that's going to be 5x plus 2 over 5. And that does not give me x because this is 5x over 5 plus 2 over 5, which is not equal to x. So that's x plus 2/5, which is not equal to x. Therefore, it's not an inverse because if one of them fails, then I don't have to continue. So this is not, they're not inverses because f of g of x was not equal to x. Therefore, we don't have to go to the next one. We could have checked the next one. We could have done g of f of x and then notice that's 5 times x plus 1 over 5 plus 1 So this is x plus 2, which is not equal to x. So both of those conditions fail. So we've shown whether something is an inverse versus what's not an inverse. Now, what if we want to find the inverse directly? What are the steps? So the steps to find the inverse is we replace f of x by y. We interchange x and y, we solve for y, and then we replace y by f inverse. So this notation, f inverse, means f inverse. So you first replace f of x by y, you interchange or you swap. So you swap x and y, and then you solve for y, and then you replace y by f inverse. And that's what we want to do for the next example. A one-to-one function is given. Write an equation for the inverse function. Well, first, we want to find f inverse. So to find f inverse, we first change f of x, set that equal to y. So it's going to be y equal to plus 1/2 x. Then we change x and y. So then from here to here, you swap x and y. So then you solve for y. So I'm going to move the 2 over. X minus 2 is equal to 1/2 y. Multiply everything by 2. And I get 2x minus 4 is equal to y. But we finish by having y to be now f inverse of x is going to be equal to 2x minus 4. And that's going to be my value. So that is exactly my inverse function. How do I know it's true? Well, I'm going to check. F of f inverse should give me x back. So then it's going to be f of 2x minus 4. And that's going to be 2 plus 1/2 times 2x minus 4. Let's check. I get 2 plus x minus 2, and that's equal to x. So yes, they are inverses. We've checked. Now the next thing is we want to graph. We wish to graph 2x minus 4. We start with the y-intercept -4 down here, and then it's up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So there's that equation right there. That's 2x minus 4. This is f inverse of x. So we are able to graph and identify our f inverse of the function. Okay. Now let's move on to question 11. Question 11 is a little bit trickier because we have a rational. That's okay. So step 1, change f of x to y. So it's y equal 3x over x plus 1. And then you swap x and y. That's the next step. So you get x is equal to 3y. So that's step 2. You are going to swap x and y. So it's 3y over y plus 1. And then you multiply by the denominator. You want to solve for y. And you get xy plus x is equal to 3y. Now you want all the y's on one single side and the x's on the other. So what you can do is bring the xy over. So I get x is equal to 3y minus xy. And then you factor out the y. And you get 3 minus x. And then you're going to divide it out. So y is going to be x over 3 minus x. And then finally, you change y to y inverse. So y is going to be f inverse of x is equal to x over 3 minus x. And this is going to be your inverse function. And then again, after you find it, you want to test it. You want to check. So you need to check or verify that f of f inverse is exactly x. So it's going to be f of x over 3 minus x. It's going to be 3 times x over 3 minus x over x over 3 minus x plus 1. Now, this is going to give you 3x over 3 minus x all over x over 3 minus x plus 1. Then you multiply it by the LCD, which is 3 magic 1, 3 minus x over here, and 3 minus x over here. When you multiply it to the first one, you'll just get 3x on the top all over. The 3x will distribute, and you'll have x plus 3 minus x. All right, so you multiply by the LCD. So this is cleaning up your fractions. So you get 3x over 3, which is x. So you just verify that indeed this value right here, x over 3 minus x, is your inverse function. Now the last piece is you want to graph it. So to graph it, you could use your graphing utility. So it's going to look something like this. So the black, it's x over 3 minus x. So please go ahead and use your graphing utility. That way you're able to look at the comparisons between the original function and its inverse. So take a moment and graph that on your graphing calculator. Okay. Now, number 12 is a little bit special because you are restricting the domain. You are restricting x to be strictly greater than or equal to 0. So you're only looking at one piece. So see how you're only looking at one piece of the parabola. And that's important. So the first thing is step 1 is change y to be x squared plus 3. And then you do swap. So step 2, you swap x and y. So you get x is equal to y squared plus 3. And then you solve for x, so x minus 3 is equal to y squared. Now you take the square root of both sides, and you have the plus or minus. However, you're only going to look at the plus, because since x is greater than or equal to 0, then y is strictly greater than or equal to 0. So I'm only looking at the positive, because I'm restricted. So then y is going to be the square root of x minus 3, the positive version. So where is x minus 3? Well, remember, if I'm in the square root of x minus 3, I'm shifted to the left. Sorry, to the right. 3 units. So it's 1, 2, 3, and then from here, I have this arrow behavior. Now, before I graphed, I need to check that f of f inverse of x is equal to x. Remember, my f inverse of x is equal to the square root of x minus 3. So let's try that. So we'll have f of the square root of x minus 3 is going to be equal to the square root of x minus 3 quantity squared plus 3. Remember that a square and a square root cancels. And I have x minus 3 plus 3. The 3's will cancel and I will get x. Well, remember, x has to be strictly greater than 0. So in order for me to have an inverse, I do have to restrict the domain for a quadratic. Restrict the value of x to have an inverse. Because if we don't restrict that domain, then we have a plus or minus where it's the danger. But if we are only going to look at the positive value, then we will have an inverse. Now, the last question is the graph of a function is given, graph the inverse. Well, first, let's start by identifying the points that were given. So identify all points. So the first point is going to be -4, -2. And then we'll have the point -3, 1. And then we'll have -1, +2. And then we have the point 1, 4. Well, that's going to find the inverse. Remember, you swap x and y. So instead of -4, -2, it's going to be -2, -4. So -2, -4. It's going to be 1, -3, 1. Let me change this one. So the first one is -2, 4. That's right here. Oops. -2, -4. And then 1, 3. Or 1, -3. 1, -3. And then 2, -1. So I'm swapping each of them. 2, -1 right there. And then I have 4, 1. So then the graph will look like this. And that is going to be the inverse. And that's the graph of the inverse. And it's separated by the equation y = x line. So I had to find the swaps. And that finishes section 3.1. Thank you. See you guys next time. Bye-bye.